Finding side lengths of right angled triangles using trigonometry, and we're looking at finding the numerator. So let's look at these two triangles here. We have a right angled triangle, circled it in red. We know how to find the side C. We can use Pythagoras' theorem because we have a right angled triangle and we have the other two sides given. What if we have a different situation where we have a right angled triangle? We've got different information. What if we've got a side, we've got an angle, and we have to find another side? We have different information. We can't use Pythagoras' theorem because it doesn't have any mention of angles in it. So what do? The answer is we use those trig ratios that we've been learning about, sine, cosine and tangent ratios. Here's a couple of quick examples putting together the things we've learned so far in the first couple of videos on trig. So we have here a triangle. We have a side x, which we don't know. We have a right angle, so it's a right angled triangle. We have a hypotenuse of 3, and we have a little angle of 30 degrees. What we do is, we know because we have an angle and a side and we've got to find a different side, we know we're going to use trigonometry. So we have to decide first of all which of the three trig ratios we've got to use. So old hippies can't always hide their old age, whatever helps you remember it. Well, what have we got here? We start at the angle given, 30, and we look at what's involved in the question. What sides of the triangle are involved? We've got an opposite and we've got a hypotenuse. Opposite, hypotenuse. Sine. Sine theta is opposite over hypotenuse. We write the rule down, then we substitute in what we have in the particular question we're doing. Opposite is x, hypotenuse is 3. Theta gets replaced by 30 degrees. So we have sine 30 equals x over 3. Thing to remember that even though it's got letters in it, sine 30 is just a number. Okay, so it's sine 30 is some number that we can work out. So we have a number equals x divided by 3. From the previous video and your previous work in maths, we should know that to get x by itself we need to multiply both sides by 3. Let's swap it around. And now let's multiply both sides by 3. So I'm timesing both sides by 3. This was in the previous video. And on the right hand side we have 3 times a half. On the left hand side the divide 3 and multiply with 3 cancel, and x equals 1.5 meters. One final example here. So we have to find the length x. We're given an angle, a side and another side. So let's write down, to help us select which one, Sokotoa. Some old hags can't always hide their old age. We always start at the angle given. The angle given is 42 degrees. What have we got here? We've got an opposite side. It's opposite the angle. We have an adjacent side which is next to the angle. We have an opposite and an adjacent. Which one involves O and A together? Opposite and adjacent is tan. So let's write down the rule. Tan theta is opposite over adjacent. You can just write O over A if you like. We put in the numbers we've got for this particular question. Opposite is x and the adjacent is 7.2. Theta was 42 degrees. And this is like the last one where we have to multiply both sides by 7.2. And I'm also going to swap the sides because the unknown is nicer to have on the left hand side, most of us would agree. Okay, so we've got to multiply both sides by 7.2. We can see there that we've multiplied both sides by the same thing, 7.2. What you do to one side, you have to do to the other side. Leaves us with just x, and we get our calculator and we go 7.2 times 1042, and once we do that we get 6.48, and this was in meters, so we put our units in. Time to try some trig.